Our lesson today is over Newton's three laws of motion. The first law of motion is the law of inertia. The second law is the law of force and acceleration. And the third law is the law of action and reaction. So before we talk about Newton's laws, let's review a minute the things that we've learned. First, speed equals distance over time. Remember, speed is the distance traveled in a given amount of time, and we find it simply by dividing distance by time. There is constant speed, where we may be traveling down the highway at, say, 65 miles per hour. That's a constant speed. And then there's average speed. It's the time that it took to travel a given amount of time. The time that it took to travel a certain distance. Like Houston's 125 miles from Lufkin, and we traveled 2.5 hours. So to find our average speed, we would simply divide the distance, 125, by 2.5 hours or 2.5 hours, and that would give us our average speed. Velocity includes both speed and the direction of travel. If we are traveling to Houston, we would be traveling south at, say, 60 miles per hour. That included both the speed of our travel and the direction of our travel. Acceleration is a change in speed or direction. Remember, if we are traveling, say again in a vehicle, if we press the brake pedal, we are accelerating. If we press the gas pedal, we are accelerating. If we turn the steering wheel, we are accelerating. All of those things are acceleration. Force. A force is simply a push or a pull. Forces, remember, can be balanced. If all the forces acting on an object, the sum of all the forces are zero, then it's a balanced force. And an unbalanced force is where the sum of all the forces do not equal zero. And in that case, the object will accelerate in the direction of the greater force. Force is measured in units called newtons, and that is abbreviated with a capital N. Alright, so let's talk about Newton's laws of motion. His first law of motion is called the law of inertia. And inertia is the tendency of an object to remain at rest or in motion at a constant speed and direction. So the first law, the law of inertia, says that an object at rest will remain at rest, and an object in motion will remain in motion at the same speed and in the same direction unless acted on by a force. Let's take a look at the pictures that I have along with the video here. The first picture shows a book sitting on a table. We all know that that book is going to sit there until something comes along and moves it, like in the second picture. It's just not going to go anywhere unless some force acts on it. Objects in motion tend to stay in motion at the same speed and direction unless acted on by a force. The Earth, for example, is orbiting the Sun. The Earth is going around the Sun, and it has inertia. In other words, it is going in one direction. But there is a force acting on it, and that's the force of gravity. The pull between the Earth and the Sun, is pulling it constantly towards the Sun. So those two forces together create an orbit of the Earth around the Sun. Now, we experience on Earth, if, say, for example, you hit a baseball, and that baseball travels in a direction, It doesn't continue though, does it? Then you know that the forces acting on it are gravity pulling it towards the earth, and also friction in the air and friction on the ground. Once it gets to the ground, it's going to stop rolling. But where there are no other forces acting on it, like in space, that object will remain at a constant speed and a constant direction unless it came in contact with some other force that changed that tendency to move in that direction and that speed. Newton's second law of motion is called the law of force and acceleration. The law of force and acceleration says that an object acted on by an unbalanced force will accelerate in the direction of the greater force. Again, let's use baseball as an example. If we have a baseball player that's hitting the ball, he's got the, my artwork may not be too great here, but he's got his bat up, and there's a ball thrown towards him, moving in this direction from the pitcher. Then the ball gets to the batter, and the batter swings his bat towards the ball, and he hits the ball. Then the ball is going to move in the opposite direction where it was going because a greater force is acted on it. And the bat is moving in this direction, and the ball moves in the direction of the greater force. Newton's third law of motion is called the law of action and reaction. The law of action and reaction simply says that for every action there is an equal and opposite reaction. Now we could again use the baseball bat and the ball. The action is that the batter swings at the ball, and the reaction is that the ball accelerates in the direction of the bat. Another thing that you can look at in the classroom is Newton's cradle. If we draw back one ball on Newton's cradle, and then we drop it, what's going to happen? Well, the reaction is that this one ball is going to move in this direction. It's going to fall back then and strike the three balls here. And this other ball, again, is going to move back in this direction. And this will continue for a while. But you have to remember that there are other forces acting on this as well. And that would be gravity and friction from the air. And so eventually it will stop. But think about it. What if you took both these balls here and pulled them back and dropped them? What then would happen? Think about that and play with the Newton's cradle in the classroom and experiment. Try 2 balls, try 3 balls, try pulling 2 back at once and dropping them back forward, and see what happens. So these are Newton's laws. His 3 laws of motion, the law of inertia, the law of force and acceleration, and the law of action and reaction. And that is our lesson for the day.